now for the last thing in this section, we are going to look at something called the indefinite integral. Okay, so indefinite integrals here. We're going to start out with our definition of these. We say that the indefinite integral, indefinite integral of f with respect to x. Okay, that's the full phrase there. Indefinite integral of f with respect to x. This refers to the general antiderivative. Okay, so this is the general antiderivative of that function f, and it is denoted by the following notation. Okay, so here we're going to get a new symbol. Okay, it looks like this. Okay, kind of a long, stretched out S type of shape. That is called the integral sign. So integrals are going to be a new thing here in the last part of this course. Okay, so that's an integral sign. We are taking the integral of f of x. So you put your function right there. And then with respect to x, remember in our derivatives, that was like the thing on the bottom in Leibniz notation. If we said like derivative of y with respect to x, that was dy dx. So with respect to x was the dx part. And it turns out you actually just write that in here too. So this is the integral of f of x with respect to x. So integral of f of x dx. Okay, so big box on that because that's some new notation. So we said here that stretched out S type of shape, that's the integral sign. The function f of x inside your integral, that's called the integrand. Okay, and then in the dx here, this tells you x is the variable of integration. There are some more terms that are part of this definition here. Okay. So if we want to write this another way, because yeah, we had that other notation for the general antiderivative that we saw before. We just called it big F of x. That was back a little ways. General antiderivative. So the general antiderivative of little f of x is big F of x plus c. We're going to go back to that idea here with these antiderivatives, indefinite integrals now.
Oops. Oops, sorry. Sorry, I couldn't.
Missed something there?
Yeah. Just accidentally just
Oh, having some Zoom issues?
I accidentally put the screen. I closed the screen.
Gotcha.
Logged out.
We'll keep looking at our definition here. So to write this another way, written another way. All right, to go back to that general antiderivative type of notation, you could say the indefinite integral of f of x with respect to x. Okay, that notation is really just a new way of writing capital F of x. Okay, so This means big F prime of x equals little f of x. Okay, so that's another idea right here. The general antiderivative, capital F of x, that's just what we're talking about with this new notation, with the integral sign. Okay, so when we see problems like this next one here, find the indefinite integral, this really just means find the general antiderivative. Okay. The general antiderivative, which we have gotten really good at today, and actually Arshdeep's got our first one there. So our function, the little f of x we're looking at inside here is the 8x cubed minus 3. And so yeah, he's got 2x to the 4th minus 3x plus c, and that's exactly right. So that is the general antiderivative of 8x cubed minus 3. We can check that by taking the derivative of it. So 4 times 2, that would be 8, x to the 3rd power, and then minus 3, and derivative of c would be 0, so that checks out. All right, so yeah, that is our indefinite integral. Yeah, good job on that. Okay, so the next one, we switch up our variable a little bit, but the idea is still exactly the same. We're doing the indefinite integral of secant squared theta with respect to theta. So this variable in our function matches the with respect to variable right there. That's good. Our variable of integration matches. So you're just going to treat that exactly as if those were x's instead of thetas right there. So we're looking for the general antiderivative of secant squared theta. So that's the derivative. What's the antiderivative? There it is. Yasmin's got it. Tangent of theta, and then the plus c. Very good. So tangent of theta plus c, that is our general antiderivative there. If we were to take the derivative, it does equal secant squared theta, so that is good. And so yeah, that is the indefinite integral of secant squared theta. Cool. Okay, and then the last one here is written in not the best form, so sometimes we do have to switch things up on that a little bit. So let's start getting this into a more friendly notation here. Keep the integral sign here because we haven't actually done that antiderivative process yet. So this is showing that we haven't taken the antiderivative yet when we keep that symbol on there. And so I'd write this as 5 plus x to the 1/3 power divided by x squared dx. And then just like, I think I don't know if we've done anything particularly like this recently. Did we have a general antiderivative one like this? Oh no, we didn't have one exactly like this, but we had a similar idea. Like this one right here, we couldn't just take the antiderivative of each part and multiply them together. You also can't just take the antiderivative of each part and divide them. So we're going to have to simplify algebraically on this expression. Okay, so let's go do that. Okay, so algebraically we'll simplify this by splitting up our fractions here. Keep that integral sign. We haven't done the antiderivative yet. 5 over x squared plus x to the 1/3 over x squared dx. And then we can simplify those powers of x a little bit. So integral sign 5x to the -2 power plus, okay, that would be 1/3 divided by 6/3. So that would be -5/3 on x there. Almost didn't write the x. Okay, so 5x to the -2 power plus x to the -5/3 dx. Okay, Now we're ready to get our antiderivative. So let's see, who would like to get this one? Now that we've written it nicer. And there it is, Felipe. All right. -5 x to the -1 power minus 3/2 x to the -2/3 power plus c. You nailed it. Very good. If we were to take the derivative of that, we would see it would give us exactly this integrand function back. So that's what we're looking for. This is the general antiderivative, so that is the indefinite integral. All right. So yeah, and you could also write those negative exponents in a different way, but that's the basic idea. So awesome. Yeah, indefinite integrals just mean find the general antiderivative, and we get that new symbol, that integral sign. And so yeah, integrals turn out to be the opposite of derivatives, okay? Because an integral matches up with an antiderivative. So integrals are the opposite of derivatives. And that's one of the biggest things we're going to get out of Calc 1 here is a new pair of operations. So like, you know, when you first start out in math, you learn your numbers, of course, but then you learn about adding. And then the opposite of adding is subtracting. And you learn about multiplication, and the opposite of multiplication is division. And we kind of go through a lot of math with those pairs of operations, add, subtract, and multiply, divide. And then, you know, at some stage you get like powers and roots, and those are the opposite of each other. And you get, what do you get? Exponentials and logarithms are opposites of each other. And then we got derivatives and antiderivatives, which now we're going to call those integrals. So we get derivatives and integrals, and those are opposing operations. So yeah, it's kind of like we're adding some new stuff on here. There's more operations out there. It's good to know.